Okay, thanks for meeting me in part two. Like I was saying earlier, in Western Washington, the rainy season generally begins in mid-fall and lasts until mid to late spring, with summers and that are dry and early falls that are dry. Um, and again, both watersheds are used as sources of drinking water for some of the municipalities around Seattle and Seattle itself. Um, and because they are trying to protect the area, there's not a ton of activity that happens there in terms of recreation. So there's not a ton of high quality photos. So sorry, it's not a super fun slideshow. Um, and snowpack is also, like I said, a contributor to the flow levels that we see in the hydrographs. However, I wasn't able to pull in snowpack data in time. I'm going to look into that more, and I'd like to include that some sort of analysis in here if I can. But we'll just have to see. So my tentative approach and my results so far. So I'm still exploring this, but this is what I have so far. Um, so my basic questions were like, how similar is discharge between the two watersheds? So to look at that, we could compare the hydrographs, which I've included in this slideshow, some more to come, over the available time frames, and then in smaller chunks as well to see, just to make things a little more legible. And I'll also include a flow duration curve, because that would give us some more interesting data, I think. So I haven't gotten to that step yet, but I'm hoping to include that in my final analysis. I also, to help determine if one watershed is flashier than the other, or just generally has just more discharge and greater changes in discharge, we could examine a Richards-Baker flashiness index over the course of the available years. And then finally, how similar is water temperature between the two watersheds across the available time frame? So that's October 1st of 2007 to September 30th of 2016. So we could include the temperature, or we could compare the temperature time series graphs, which I've included in here, and then perhaps the 7-day average of the daily maximum temperature graphical comparison as well, but I haven't gotten to that as of yet. So here is the combined hydrographs for each watershed. So the orange is North Fork, Tolt River. The blue is the Cedar River headwaters. For the water years 2008 to 2016. And as you can see, I made the Tolt River orange curve slightly transparent so you could see more of the blue. It's not shown up great in the slide now I'm looking at it, but you can see that they have very similar discharges, which is pretty interesting, and expected for the most part, given how close they are. But it's pretty cool that they have pretty similar discharges, even in terms of their overall level of discharge. And then here's the water temperature data for the same period of time. Again, you see that large gap with the Cedar River data set, and then that moderate sized gap for the Tolt River. But as we would expect, given how similar discharge is, they also have very similar water temperature levels as well as it goes through. Even some of the magnitudes of change are similar and of the same patterns. So, but overall, the North Fork of Tolt River seems to be slightly warmer. And then here's the flashiness index that I indicated earlier, but this is for the entire range of the data frames that we have. So late 80s to about 2020. One thing I didn't mention is that the North Fork Tolt River switched to a different gauge for its discharge measurements, which I didn't include in here because I figured I have enough data to satisfy my my analysis. So yeah, as you can see, greater amounts of change and quote-unquote flashiness in Tolt River as compared to the Cedar River over pretty much the entire frame of reference. And they also have the same patterns as well, just differing magnitudes. You can see different patterns here, but overall they match pretty surprisingly well. And so again, just to summarize, the overall idea is to quantify and evaluate the similarities and differences between these two proximal, physically similar watersheds. And as we saw in the last few slides, the discharge and water temperature data available is also similar between the two watersheds. So that gives me some pretty interesting options in terms of analysis. And I'm hoping that more comes out of the further analysis the more I get into it. And I'm still evaluating some of these options in terms of analysis. So the final product should be more complete, such as maybe including snowpack data if that's reasonable, and if I'm able to do that, assuming that there's that data available. But yeah, overall, it's been pretty interesting looking at these two data sets and exploring those, just pulling data sets from USGS and seeing what I can get into. Yeah, thank you so much for joining me. I hope you have a good day. Thanks.